Hey folks, so here is the terminology for section 11.4. Let's start out with simple closed surface. It's going to have a connected interior, there's no holes, and it is completely hollow. If we go down then to the next one, we have solid. This is a simple closed surface, what we just talked about, combined with its interior, so it's no longer hollow, it's a solid. Polyhedron, the plural form of that is polyhedra. Sorry about that, that is misspelled, so if you would fix that on your notes, please. Polyhedra is the plural form of that. So we have here a polyhedron or polyhedra. This is going to be a simple closed surface, so what we just got finished talking about, made up of polygonal regions. Those polygonal regions are going to be called faces. The vertices of polyhedron, these are going to be the vertices of each face, and the edges of polyhedron are going to be the sides or the segments of each face. A sphere, this is going to be the set of all points, a given distance from a given point. This actually sounds a whole lot like the definition for for circle that you had back in section 11.1. The difference is that for circle, everything was on a single plane, but for sphere, it's the set of all points, not just all the points in a plane, but all points. Then if you'll go down, we're going to be working through these questions here during class. Go ahead and go down to the section that starts with prisms. And so we're looking here, definition for prism is going to be a polyhedron, so all of those things that we just talked about, where two congruent polygonal faces lie in parallel planes. Let me show you what we're talking about here. If you'll notice this picture below, I have a triangular face here, and in a parallel plane, there's another identical congruent triangular face. So I have two triangles in parallel planes. These are going to be called bases. The remaining faces are formed by line segments joining the corresponding vertices of the bases. And you can see here, I've got a line segment that joins those two vertices, and another line segment that joins those two vertices. Go on down, please, to cylinders. And we will come back and discuss prisms and all of these other things when we get to class. We'll be working with some examples and some hands-on stuff, but for right now, I just want to get the terminology down. A cylinder is the union of line segments joining the corresponding points on two parallel simple closed curves. All right, let's put this in English. Honestly, folks, this is basically the same concept of a prism. The difference is, look at my two bases. My two bases are no longer polygons. That's the difference between cylinder and prism. Prism is going to have polygonal bases, and a cylinder, it just simply has simple closed curves for bases. I can get a little more specific and talk about the circular cylinder, and this is where specifically my bases are not just any old simple closed curve, but it's specifically a circle. So I have circles as my two bases. Then we move down to the concept of pyramid. Pyramid is formed by a polygon base. Notice a polygon base, there's only one. And a point, this point is called the apex. The apex is not on the same plane that the polygon is on. So let's stop right there. Notice down here, I have a triangle polygonal base. And then I have this point called the apex, and it's somewhere that's not on the same base, not on the same plane that the base is on. The edges of the pyramid are formed by line segments that join the vertices to the apex. So you can see here, this is a line segment that's joining my apex and my vertex on my base. And then I have cone. So a cone is formed by a simple closed curve, that's your base, and a point not on the same plane as the base. Again, that point is called the apex. And this is the same difference that was between the prisms and the cylinders. The pyramids and the cones have the exact same difference. So you'll notice here that my base is a simple closed curve, whereas the base on the pyramid was a polygon. The circular cone is a little bit more specific. It just simply says that the base has to be a circle, not just a random simple closed curve. Continuing on. Go all the way down, please, till we get to regular polyhedra. Regular polyhedra. And here, regular polyhedra, this is going to be a convex polyhedron where all of the polygonal faces are going to be congruent to each other. They're all going to be congruent to each other. And you'll even notice as you look at these 5 famous regular polyhedra that each one of them is either made up of equilateral triangles or squares or regular pentagons. All of them are made up of faces of one of those 3, all of which are regular polygonal faces, congruent polygonal faces. And then the last definition that we have for this section is going to be net. This is simply a pattern that we're going to use to construct a polyhedron. And you'll see a couple of examples of nets below, and we will talk more about nets during class. But this is just simply something that you could cut out of paper, and on the dashed lines you would fold, on the solid lines you would cut, and it would form a polyhedron once it is folded into a 3-dimensional figure. And I believe that's all there is as far as terminology for section 11.4.